these ones are, they're just counters. These actually check your identity.
Well, I mean, everyone's going to be, it's going to be a round table. Is there a way we could put that table in the middle and put the lapel on it?
Sure.
Does that work?
Put the lapel on you.
On me?
Put the handheld like that. Or what I have been doing is walking around and awkwardly standing next to people holding the handheld. Because it's for recording, not for...
Well, I'm not going to focus on getting it recorded rather than the quality
exactly.
for the people
and,
here.
and that's exactly what we said is like, ignore the mic. But at the very least, let's pick up what you said.
That sounds good.
I think.
All right. While you guys are coming in, I have these cardstock. So I'd love to see, and fold it this way so everyone can see what you're doing. But I'd like to see on it your name, your company, and then we're going to do a little computational design Power BI manual. This is going to be from non-computational designer to I make everything and I'm an Autodesk developer. And this size is the size of my company. And then the size of the dot is how big your computational design team is at your company. Is that too much? All right.
That's complicated.
So, for example, my name is Tim and Hazel. I would write Tim and Hazel here. My company is Silman. And I put a dot about here because I make a lot of things. And I have, well, yeah, and my company's over 100-ish. So 0 to 6,000, non-computational designer to I make everything myself.
So that's just where the dot goes.
That's just where the dot goes. Yeah, you're not drawing the whole graph.
And then what do you do for the size of your team?
The size of your team, the size of the dot. So if you have like a really big computational design team, then make it really big.
This is
If
relative.
it's small,
Whatever you think
yeah,
is a
whatever
big
you
dot
think
versus
exactly.
small.
Yep.
Okay.
Now, the company size, is that total staff, or are you talking
Total
about
staff.
Revit staff? Are you talking about designers?
You decide. You're going to describe it to us later.
We're using just paper.
Here, there's cardstock.
So all your phones.
Oh, I know.
Oh, it's 301.
There's some markers going around. Pass these around. Sometimes easier to read.
So,
On any paper that works for you. Yeah. There's a cardstock. Here you go. Here, actually, do one here. This one's
So you wanted it folded?
Oh, yeah. Like what do we call that? Hot dog. Hamburger, that's right? That's, you fold it like a hot dog or a hamburger?
oh yeah, that's right.
Someone taught me that when I was a kid.
All right, you want to get going?
I think so. Where's the mic?
He's going to take care of this. So the mic is for recording, not for amplification.
You're the ones right here.
I feel like I'm getting on a roll on all the structure classes again.
Oh,
I haven't
yeah.
gotten them all, but there was one year where I think I introed every single structural class. And you guys were tired of every year.
First training.
All right, ready?
Yeah.
All right, this is Timon. Timon is one of my favorite speakers because, well, if you know him, he has a lot of energy. And the first time he attended this conference, he came up to me and was like, "Oh my gosh, this is so great. I want to speak." And I'm like, "That's great." And he got so excited. And the next year, he submitted his class, and we remembered him because of his enthusiasm. We're like, "Yes, we're going to take it." So we took it, and then his class was awesome. And it was just such a cool thing to have somebody so enthusiastic to come and become a speaker. And now he's a regular speaker. So I'm sure this is
Fifth time. Fourth time speaking.
Wow.
Third time. Fifth time attending. So,
5 years already.
yeah.
Well, welcome, and enjoy your chat.
All right. As you said, my name is Tim and Hazel. I work for a structural engineering company, but most of the things that I do these days is actually computational design. What is that? We'll define that in a minute. But a little bit about my firm. We're a team of 150 people, that's considering the entire company, and that's probably about 80 or 90 structural engineers. We have about 10 to 15 BIM experts. Myself, I do most of the computational design in our firm as far as like creating new material, but we have 3 other people who are dabbling in it, and about 8 people who are moving up into Alliance to try to be involved in different ways. They might be engineers, they might be BIM experts, and so that's a little bit about myself. As for those who weren't here earlier, what we're doing is we're taking and we're making little name tags. What I want you to do on the name tags is fold it this way, write your name and your company, and then so that other people know a little bit about you when you're speaking, I'm asking you to put a dot on the paper that represents in one direction how computationally savvy you believe yourself to be. So from non-computational designer or constructor or whatever, we're using the word designer pretty broadly here today, to all the way to I make everything, I'm Autodesk's primary developer. So that would be the other side. And then from the bottom up, we're going company size, so 0 to 20, 20 to 100 or 200, 100 or 200 to 600, and then maybe you have a couple thousand people in your firm. That gives us a little bit of context, so when someone's speaking, you know in your head where they're coming from and the things that they're saying. So I'd like us to start with a little bit of other introductions. If you could pull out your phones right now and go ahead and pull up the handout. I believe that it will be helpful for you to have the handout. I considered printing it. I decided to go a little bit more green. So you can do that by going to the app, going to the sessions. In the sessions, you can search computational if it's not already listed in your sessions, and then open as Computational Design for Everyone, and then download or open the handout for today's session. Give me a minute to do that. Everyone found the handout? Anybody having problems finding the handout? So a little bit of overview. First of all, rules of engagement. My hope is to see everyone who's here to talk. You don't have to be an expert to speak. We all have thoughts and opinions. Obviously, you came in here because you want to be a part of a roundtable, and part of a roundtable is your discussion. So maybe at the end, when you rate the discussion, are you really rating my ability to present or your ability to participate? So consider that a little bit as you're participating, that you are the ones that make the conversation. I'm not the one here to have the answers. I will facilitate. I will be a part of it. No question is a dumb question. We're here because none of us are experts, and all of us want to grow in our space. So rules. Other things about the rules. One big question is that nobody dominate. So one of the ways I'm going to tell if someone's dominating is if there's a conversation between 2 people happening. If there's just a conversation between 2 people happening, I'm going to ask you to pause and bring a 3rd person into that conversation. They'll bring another voice and help us round out that table a little bit. And then from there on, other than that, we'll just go, I will move along. We have, I always say 4 or 5 parts, but we'll start out with this is our intro, and then we have, I'm framing it as far as yesterday, today, tomorrow, and then summary. So yesterday, as you can see in the handout, what were we doing? What did things look like? Today, what are they looking like today? Where are we growing? What do we want? And then tomorrow, where are we hoping to get? And we'll talk about that a little bit. We'll also talk a lot about what is computational design. What do we expect from computational design? What do we expect for roles of computational design? And I sometimes might just say CE because it's a long word. And then we'll end with a summary. Depending on how the time goes, we might do a couple other activities, but there will be a couple times where I'm going to ask you to look to your partner at your table, or 3 people, and together work on something, and then together each of those groups is then going to present something. So if that happens, the people in the middle of that group just kind of pull backwards, the other people come towards the inside, like maybe I see, these three people, they might collect together so that we can move along and then be ready to present whatever your findings are from that conversation. So I'd like to start with introductions for everybody, and with these 4 things. Again, we talked about your images will help us understand that. But firm size, what's your role in the firm, a person in this industry who has inspired you in any way, and then one question you would like to see answered. And Kyle, can I actually get you to write down some of these questions that people want to get answered? You can just flip that over to the next slide. Yep. All right, so I already said, but I'll go through quickly. My firm size is about 150. My role is I'm a BIM manager and head of computational design as I try to drive our company more in that direction. A person in the industry who has inspired me. I don't know if you've heard his name or not, but Isam is the developer of PyRevit, and I'm inspired by him because he gives a lot free to the industry, and I'm just impressed at the way that he does that, and he has made a lot of the work that I do possible at a much easier level, much more tangible level. So I'm really grateful, and his generosity to our industry really inspires me. One question I would like to see, I would like to have a better idea of what expectations are at other companies for a person who considers themselves a computational designer. All right, can we go around?
Sylvia, I'm from business. There's about 250 of us, but only half of us do building design, the other is more civil side. Person that inspires me, actually persons, I've been coming to RTC for 7 years now. So a lot of peeps that started this inspire me a lot. Question, I'm new to see all together. I just want to figure out
A little bit
if
about
that fits. What fits? Does it fit me? Does it fit my firm? Does it fit my future?
Great.
My name's Andrew Atkins. With HGA Architects and Engineers, we are about 900 people now across 11 offices. I am a structural engineer first, a BIM leader second, and then I just dabble with like anyone. So definitely not like a go-to computational person, but play around with it a little bit. A person that has inspired me is probably known to most people, but Marcelo, just because he's a structural engineer, allegedly. I don't know, but he just does so much more above and beyond that, and super smart, but also down to earth and fun to talk to. I think I would just like to, the question I would like to see answered is kind of just how other firms are approaching your computational teams and workflows, whether it's kind of like a point person or a little mini user group or task force, and compare that to what we're doing.
My name is Landon DeFelice. I'm from NAC Architecture. We're about 150 people in 3 firms. I am an architectural designer, almost licensed. Last test coming up soon. Person in the industry, I'd say David Rutten, who's developed Grasshopper. He's just like super active on the message boards and really helpful, and kind of brought those tools to a lot of people. And one question I'd like to see answered, I guess I'd just like to see how computational design is being used in other people's firms and the role it's playing in sort of their process.
I'm Andrew Sternberg. I work for Stantec. I'm an architect and a BIM lead in our Philadelphia office. Our company is about 20,000 people, and our buildings group is about 3,000 within that. We have about 100 people in our Philadelphia office. 50 of them are architects and interiors. We have a small group, maybe 5 or 6 people that are dabbling in computational design in some form. I'm relatively new to it, so I'm trying to properly support their interest in it and just help them find opportunities to leverage those tools on projects.
Hello, I'm Allie Bosarge. I am a design technology specialist from Shepley Bulfinch's Boston office. What's the other question? We are about just over 230 people across 4 offices and growing, so that's cool. And so I'm a design technology specialist. My background is interiors, so that's raised a lot of interesting questions for me, especially coming here. But we have a team right now of 6 to support all of our people. So we are trying to create and implement more things across, or to get this knowledge and technology out to others. So I guess something that inspires me is, I don't really know them by name, but Grasshopper is what first kind of got me interested in computational design. So I would say that guy. And I think one of the questions that I have is, how can we most easily create tools that people can not only just use but also learn to use, and then how can it be applied from an interiors standpoint too? Because I think it's something we don't really look at. It's more implement and just whatever, different scope.
Matt Sweeney from PES Structural Engineers. We're about 50 people with 2 offices. Our computational design team is largely me, with a little bit of help from 1 or 2 other younger folks that have some interest, but don't really ever get the time to get into it. As far as people that would inspire me in the industry, I'd say a lot of it's more than one. Folks like Tim, Marcelo, John Pearson, the folks that seem to have the drive to just keep going on this stuff, even though it's not their primary job. Yeah, I don't know how you guys find the time to do some of it, but and then lastly, a question would be, what are other folks doing to kind of encourage some of the younger folks that are engineers or architects, whatever it is, but how are you getting them encouraged to go in the computational design roles while they're still focused on engineering? How do you kind of foster both, I guess? Because as I said, we've got some younger folks that seem to have that drive, but they want to and probably should go through and get their, whether it's certification in architecture or PE, those kind of things. So, kind of being able to bridge that gap.
I'm Emily Ormsby, also with Stantec, about 20,000 people, as Andrew had said. I'm a mechanical designer, and I also do BIM model management in our office. My office is kind of small. I'm from Binghamton, New York, and we have, on a full day, 25 people sitting in the office. So even though we're part of a big firm, we have a very small group. Big E, little a, also in our office, which is kind of unique. A person in this industry who has inspired me, our previous BIM manager in our office, Mary Vanderpool. She was always very steadfast in doing things properly in the model and understanding the effects that you have on the rest of the project through doing that. And I don't know, she really inspired me to have an understanding of how to use these tools most effectively, not just to do it so that it looks right on a sheet of paper. So I guess one question that I would like to see answered, I guess our group is a very diverse group. We have some pretty proficient Revit users, and then some not so much, so I'd be interested to hear how to effectively implement computational design to an office that is diverse like that. Yeah.
Hi, I'm Christina Gardenhire. I'm from Lionocus. We're big A, little E structural engineering, mostly in California and Hawaii. We have about 200 people, and I'm the director of design technology. Dan's actually at Lionocus with me. We have 3 people primarily, and we've just dabbled in computational design and actually hired Dan to help us progress forward with it a little bit more. Somebody who has inspired me, actually I have 2. One is Bill Allen from Evolve Lab. He just has a fresh perspective on everything and is also very humble, has good energy. And Jim Martin, actually from Shepley Bullfinch, is another one. He's just done a lot of impressive things with data. And one question I would like to see answered, I guess, is kind of where we're at now is just how to better explain what computational design is to people so that they could recognize opportunities for it on their projects. we keep having people come up to us and say, we want to do computational design, like back when everybody said we want to do BIM, but they didn't really know what it was. So just like helping them help us, how to get there.
Hi, my name's Daniel Tran. I work with Christina, same firm, so I'll skip that part. I saw a lecture recently by an architect named Jenny Sabin, who's also a researcher at Cornell doing some interesting work in computational design. One question I'd like to see answered is, I'm curious about any work people are doing with sensors. It's something we've just started. And beyond that, what animation tools there are to kind of show in real time this kind of data we're working with, both with and without sensors.
Thanks.
Jude Ayton from MG2, firm of about 600 people. I am BIM specialist or design technology specialist, however you want to phrase that. I've gone through several different roles throughout different companies and organizations that I've been at. And many of those companies have different qualifications of what they define computational design as. Most of it's centric around the platform in which the majority of the users or majority of the people that are interested in computational design understand or have available to them. I want to see where this marketplace, where computational design beyond a single project and a single person can expand the knowledge of the AECO kind of marketplace.
Hi everyone, I'm Neil Kemp. I'm a structural technologist with Dialogue at our Edmonton, Alberta office. The dot here on the card is more reflective of the size of our Edmonton studio. It's about 160, but we're a little over 700 all told across 5 studios. And yeah, my role, other than on the structural technology side, I'm also working in linear infrastructure projects. I'm a coordinator on a light rail project that we're doing at the moment. And somebody who inspired me in that field was at last year's event, if anyone was there and saw Lauren Schmidt's presentation, a landscape architect, who's doing some great work on the civil landscape side within this field. And the question I'd like to see answered is along that line. It seems as though a lot of the topics within the conference have to do with linear infrastructure, like rail projects. It seems quite thin, and so I'm just curious as to anyone else's experiences with advancing technology within the infrastructure field, and just get people's opinions on that. So,
thanks.
My name is Kevin Carroll. I'm the BIM manager at Magnus & Clemensic Associates. We're a structural engineering company, mostly here in Seattle. 200 people, or 225 now, mostly structural. This is a hard question to answer. My first response was all of the forum leaders at redditforum.org, and because when I first started doing BIM management, there was zero information out there, and most of the quality stuff came off that site, so it was very helpful to me. And Aaron Mahler and all those folks were very. It gave me a lot of confidence moving forward with really good standards. So anyway, the question I have is how I lean more towards the practical aspects of using Dynamo every day. How does it help us produce drawings? How does it help us workflow-wise? Whatever that stuff is. So interested to see how others.
Hey guys, I'm Kyle Martin. I work at Gensler in Boston. 6,000 people, lots of offices. So who has inspired me? All the guys that develop stuff open source for the community, like John P., Andreas Dykman, who does the Clockwork package, people like Andrew Human. Those that actually develop code and put it up there for us to use are really inspiring and we appreciate it to this day. Probably should have mentioned a digital design manager at Gensler, but I sacrificed a very significant portion of my personal life to help promote computational design in the industry, and I lead the Design Militia Boston user group. We do a hackathon that we've run the last 2 years, various speaking things like at this conference here. So I'm kind of always in the fight of trying to create more technology specialists in the industry and try to promote the role that it needs to play in the future of the industry. So question would be, oh, this is tough. I'll write my question in a minute. I had a good one for that.
You gotta share it with everyone.
I think the biggest barrier to computational design right now, maybe this is more of a segue, is I think one of the biggest dangers of it is that people are starting to like the idea of it, but they don't fully understand it, so they buy in at the wrong scale. So what we're promising to our clients, what we're expecting the one computational designer in our office to do, is often a little bit burdensome, and it sets unrealistic expectations that when we don't hit the mark, actually sets us up for failure. So
Can I rephrase that too?
you do whatever you want. Put a question mark on it, and we'll make it a question.
That actually brings a very interesting question as I was listening to different people that have inspired people. Another person who inspired me actually is Jim Martin at Shepley Bulfinch, because one of the things he told me about was always consider the business value. So if I can have you walk away with 2 things from today, it would be 1, look at the people around you. We're actually going to set up a Slack channel after this, and you're all going to be invited onto it, so you can talk to each other, because these are the people who are willing to talk to you and answer those hard questions. So if you can walk away with just that kind of a small community, that would be great. Second, if you can walk away thinking, every time we think computational design, think, what is the business problem I'm trying to solve right now? That has helped me significantly create space in our company and in my time to do computational design. Okay, so now let's try to define computational design. Let's divide up into, looks like maybe 4 groups. So a group of 3, a group of 4, a group of 3, and a group of 3. And together just write out what you would consider the definition of computational design. And I'm going to give you 2 minutes to do this, so that's not a lot of time. So get started. All right, I'm going to give you 1 more minute. All right, let's take 10 more seconds to write down our thoughts. I know that's not a lot of time, but this way we can keep moving. All right, can can we get someone to share a couple of the things, and I'm just going to write down the keywords that I hear your definitions, so that together we can kind of create a maybe more of a thesaurus of computational design. But can we start over here?
Yes, Dan had a good one. Augmentation of design process with computational methods methodology.
Augmentation.
With
Can you read it one more time?
augmentation of design process with computational methodology.
Okay. Yeah.
Computational tools.
Somebody else want to share your definition? What do you guys?
So using computational thinking to solve everyday problems with algorithms and computer processes.
It's interesting how you say everyday problems, right? Normal problems. We're just trying to solve normal problems in an algorithmic sort of way. Yeah? Okay, somebody else?
Goal-oriented design problem solving using technology, software, computation.
Can you read it one more time for me, slower?
Goal-oriented design problem solving using technology, software, computation.
Okay. I feel like I'm missing something here. Probably computational design. All right. Somebody else?
So we just kind of threw words at it too, but smart, repetitive, scalable, and makes life easier.
Scalable. That's an interesting one that we haven't heard yet.
Maybe leveraging computation.
Maybe. So,
Yeah.
computational design, right? It's like using a computer to design. Let's think about that for a minute, right? So, the reason there's so much stress in this space, and if you're doing, it sounds like most people here, if I looked at your dots, a lot of people feel or find themselves more on the left side of the skill level or the experience level, is that we're kind of people who are torn between two spaces, right? We have the design space and the software development space, both full-time careers, and I at least can speak for myself, I feel torn between the two, and if I'm spending too much time over here, my brain keeps saying, you need to spend time over here, and if I'm spending too much time over here, my brain says stay more. No, I do have to keep that related because I'm not a full-time software developer. I don't really have the desire personally to be a full-time software developer, right? So there's that struggle, it sounds like. So computational design. I want to add 3 words in my definition. So for me, it has to do with generating geometry. It has to do with repetitive tasks and automating them. So I'm going to say automating here. Is that already on here? And then interoperability between software tools. That would be the 3 kind of spaces where I find my computational design falls most. What do you guys think? Do you think this is is there anything we're missing that you want to add to a definition of computational design? Data, which has to do very much with this interoperability idea, I think, from my standpoint.
Abstraction.
Abstraction, can you explain a little bit?
Well, so we have to take a problem, we have to sort of pull away from it a bit and abstract it into some parts and pieces that you find understandable.
Mm-hmm.
So you dumb it down a little bit, even though computer's smart.
Yeah, definitely.
I was going to add the sheer number of option generation. Or a traditional design process, you come up with 2, 3, 4 options, but observing what I'm seeing in these presentations, it's about coming up with thousands or millions of options.
Mm-hmm. Yeah. All right. Well, from there, I want to think a little bit about yesterday. And the questions that you guys have, I put them up here. We can get through any questions you want to have. From here, you drive the conversation. I'll direct it in particular directions. But again, we're going to talk about yesterday, today, tomorrow. Feel free to throw your questions in where you feel they're fit. We'll spend about 15 or 20 minutes in each sector, and we'll see how that goes. So here are some questions I had. I'm going to pause talking and give someone else space to start the question where they feel like they want to start the conversation on yesterday.
Something that Kyle said in the beginning, which is about when you go to implement one of these tasks, defining the scope of the problem, or misdefining it, and you're trying to solve a problem that isn't really the right problem. So it's just about being clear about what am I trying to do. I'm not going to design a whole building per se, or what is it that I'm trying to solve. Being clear about goals of the exercise.
Okay. How do you define a problem? That's the question I'm hearing in what you're saying.
It ties into the abstraction comment too about you have to analyze, you have to step back and how do we measure the parameters, the inputs, how do you measure the evaluative criteria, are they even measurable? The algorithms are going to succeed or not.
What is the way we solve problems without computational design?
Conversation.
Can you elaborate?
That's how we solve a lot of our problems, is conversation.
Okay.
Just straight up. Proactive.
Or iteration of an idea.
Intuition and like very limited sample size, like trial and error. Give a couple options and compare.
Taking people to step outside of themselves and realize what their procedural moves in the computer is doing and turning that into code.
Yeah. Has anyone heard the term domain experts? I've heard it used. Can someone explain to me what a domain expert is?
We can take an individual who's had 30 years in the practice, the architecture or whatever. They've seen how many iterations and executions of different projects. They have that retained innate knowledge of what worked, what didn't work, what did I get sued on, what did the company get sued on, what practices, what are things, how tightly should I be looking at the spec, how should I be looking at whatever, code conformance and so on. So they have a domain of knowledge throughout their professional practice. Now they're at a specific company, every single person there has a gambit of knowledge.
Has anybody seen, working with a domain expert, has anybody ever seen successes in the past or failures in trying to define a problem or in trying to work through a problem with or without someone with this kind of past experience?
Each time that we have that person available, we usually have to step in later to fix anything, and I say, might as well step in with them first. Shortcut your solution by getting them.
Yeah, so you kind of get started, kind of start working, and then how do you find out you're unsuccessful? When do you get to that point?
It's too late.
Yeah, that's right.
Liability hits you?
Yeah.
So, what about successfully? Have you ever worked with someone in the past who was a domain expert in trying to really, I think Kyle said it, step away and try to figure out what it is you do to do what you do?
I think we all have seniors that pull into a project meetings to get their feedback or experience, but I don't think my
Okay.
I found that it was common that a person really, domain expert would try and help us define the problem in the first place. Then shortcut path.
Where I've seen, especially working like with Jim, he's really good. I love sitting right next to him. I love that because like he's the type of person everybody wants in a meeting, but like he only has to be there for like a minute or two. You know, he just needs to like put the right people in the right place, and there's like an element of being able to form connections and spark conversation that allows things to like work themselves out with other user groups. Like, so you don't have to necessarily be there facilitating the whole time, as long as you can put people from each part in the same place to solve or tackle a problem.
So everyone write this idea down of bringing together a technology expert and a domain expert. Again, this might be something that we all think about every time we start with a computational design problem, but personally, I find myself digging in before pausing, stepping back, going and learning that domain, that area of expertise. And it's hard. Has anybody worked with someone who you're trying to understand how they work through something? Yeah. Can you help us understand what kinds of questions, how do you get that knowledge out of that person?
Keep asking why or how, like the 5 whys, to get them to simplify it.
Or show me, do your work in front of me, and like.
Anybody have an example maybe, rather than just like a specific example we could kind of like all hear and understand?
I go to multiple engineers' desks and just have them work through whatever it is they're trying to do. Like Kyle just said, I mean, whether it's trying to automate something they're detailing or something they're doing on drawings, whatever, but actually having them show me what it is they're doing. Because I know the way that I want to do it is probably not what they're doing, because of just the way that I tend to think about things. So I mean, like step by step, and then asking them why they just did that one, or why they did it that way, because there's times when you ask them that, they're like, wow, well, I don't know. Go ahead.
I've seen an example at KA Connect conference where somebody wanted to ask an expert how they see problems in like an existing operating room or something like that, and how do they design a new one. And they weren't really able to they don't know what you don't know, and they weren't able to really explain their knowledge very well. But then they put a photo up in front of them of like what's wrong with this picture, and it was an old operating room, and they started just like calling out different things, and you could start hearing their thought process when they were doing that. So it's learning their behaviors and their thought process, which was key.
I've found it's really hard. For people to whom it's natural to do something, it's hard to step back and think. I tell people, think like you're teaching a kindergartner how to do what you do. It's like, okay, I click here, I look at this parameter, I move it over here, and then it's spelling it out like that. It really helps. All right, what pain have you experienced in the past with computational design?
I think, like, for us, since we're we're just in the beginning stages, we're learning how to do it at the same time people are asking for it. So when somebody says, like, hey, I've heard what you guys are trying to do, I have a good problem for you, and then it takes us so long to, like, work through it that by the time we figured it out, they're, like, beyond it, and then they think that computational design is, like, helpful because it takes too long or something, like, so we're, like, struggling to get those problems to solve and learning it at the same time.
Yeah. The point about scalability is that's on the infrastructure side, that's one of the really plus, is not knowing the tipping point of when something is if there's running a script or just trying to do, how those are fitting together, and just not knowing if the end game is going to be a 0 or I think that's always tricky, to just try and find that tipping point ahead of time, which we don't always get the luxury.
It seems like kind of PR and having other people understand what it truly is, because I think it started out when people were calling it parametric design or whatever. I was like, well, wait, Revit's like already parametric, what are you talking about? And then everyone decided it was crazy geometry and like sliders and then making stuff flex and be cool like that. I think that's part of it, but it's such a narrow band of what it is. You know, computational design is so much bigger. So kind of when you get people to see that, because if you don't work on those crazy weird shapes, you're probably not going to make it.
One of our colleagues in the structural engineering, she was getting a presentation about rebar optimization. That's not just the how application. But there's definitely an issue of the type of problem. It's a math-based, very definable, goals. And it's end up we know the math behind that versus finding a space, designing a space that you how do you measure that out?
Well, doesn't it also come down to how you qualify the question? Because I mean, if you're doing, let's say, exiting, you have a certain number of count per room, and then you have the corridor width, and you have the length of the exit, and so on. You've got that. So if you're just running a script through the computer, isn't it computational design to spit out a valid number or an answer or different types of things? Or are you talking more augmentation through machine learning, having an optimized floor plate to help give you a few different options that you can then apply your professional knowledge and history to, and saying these are the more desirable ones that I'm going to select over others. So how you define that question to what is computational design? Is it just getting a single validation, or is it providing potentially multiple options? So yeah, it's hard until you figure out how you define that for yourself.
Throw in that the problem is that they don't realize they have a problem because they're doing something over and over again, taking a lot of time clicking buttons and processing information one piece at a time. And you recognize an opportunity and you sell the promise, you build the tool, you teach them how to use it, and you realize they really enjoy modifying schedules one night at a time. And that's something I can't fix.
I was going to say opportunity. I like always turning when there's too much focus on the problem, it's like when you switch it to opportunity, and it seems to really just trigger conversation.
What incentivizes people to change the way they work?
Yeah, exactly.
I think
Adoption's been painful.
Yeah, like we'll identify that here's a problem that we can solve, develop a tool for it, put it out there, and people just they're uncomfortable learning something new. I guess kind of the question of how many people need to know how to use this, and all of the steps. We've been doing stuff in Grasshopper a lot, so you have to know Rhino, and then know Grasshopper, and then know the plugin, and be able to hook it up. And our Revit install likes to overwrite our version of Iron Python, so then it's like, well, how come all the components are red? And just kidding. So I think that's been a pain. It's like, how many people should be doing this? Should we don't have a dedicated person to do this. So then there's a lot of frustration with, like, how can we spend all the time doing this? No one can use it.
Yeah. Can we jump onto that conversation for a moment? How many people should be doing this? So we define computation generally, but I also want to potentially say that, and we can talk maybe a little bit about this as the levels of computation expected for different skill sets. So let's start at the just your typical designer. What would be some ways that you would define the amount of computation you expect, computational designing, you expect them to do or be involved. How do you expect them to be involved in this?
Senior designer?
A senior designer, sure. Senior, junior.
They can define what they're trying to achieve through sketching, through communication, through email lists.
So sketching at this spot. Okay. Anything else we should be expecting from this person?
You would hope that they would understand it enough that they could help someone define constraints and parameters so that they can build.
Okay, educated enough, you're saying that they could build the tools?
They can just like say like, here's kind of my constraints, here's like the parameters or output I want to get out of it. Can you help me build something?
Okay, so someone who's able to help define the problem, help kind of spell it out, we might have to educate them in that, but they can.
It's like if they want you to build a Revit family, they're like, okay, I want these parameters to make it do this and that, but they're not going to build it themselves.
Okay.
That's
So what would you expect from someone who's fairly tech savvy in your firm when it comes to computational design?
I would say the ability to listen to the problem. So that's kind of the role that like somebody, not like it's not a BIM manager, but somebody who's like they might do model checks or take care of more persons in person. They should be able to identify like any type of like workflow that needs to be implemented using design. So they don't necessarily know how to like actually write something that could solve the problem, but they should at least be able to like identify it and translate it into a series of like actionable items, I suppose.
I'd expect them to be able to use the tools.
Oh, use the tools. Okay, that's a
Not right.
for the fairly tech
For a
savvy.
fairly tech savvy person to be able to use a tool like Grasshopper, Dynamo, not create, just get in, move a slider, understand what an input is, and be comfortable hitting the run button, or, you know, is that, I mean, I know in our office, like, getting someone to open Dynamo and look at that screen, I mean, it's just mind-blowing. And whether, they don't even have to do anything, just hit the run button. Like, there are no inputs, but they don't want to do it because, you know, I don't totally know why they don't want to do it, but they don't.
Yeah. So let's keep going down this. Okay, so now you're at a very tech savvy person. What is your, and maybe I'm defining this wrong. Do you think tech savviness is the right way to make this line? Is there a better way to define this? All right, so the very tech savvy person, what is your computational expectations from this person?
I would expect that's the way they think.
You would expect that that's
I
how
would
they
apply that to whatever the different tools, because I think computational thinking and design methods are more with Grasshopper. Right? It's a programming methodology that you can apply to paper. It's just that's their process.
Able to teach the tool.
Able to teach it. Okay, so someone who's very tech savvy should be able to teach it. Anything else from this very tech savvy person?
They should champion it, and they should be teaching it across the rest of the organization. I think that's key.
How about customer service?
Customer service?
Yeah, not just being a jerk because you're really good at the tools, but being able to communicate, to form relationships with the people that you're working with, and teach them to pass on your knowledge.
Talking a little bit about today at this point.
That's a unique person.
Yeah. Did you want to? So do you kind of hear the spectrum that we've just created? We've now said whoever's this tech savvy person, which I'm assuming is probably some of you in the room. I know you rated your scale lower for some of you on the tech savviness scale, but put yourself as probably one of the more tech savvy people in your office. The expectation now is of this person that they champion it, that they teach it, that they create all the tools, and what else? What else is often expected in our companies of these people?
They're also on their project.
they're also carrying another job.
Yeah, you have to be billable.
They have to be billable, okay?
Don't forget, you're making money.
Okay? There's something there. Everyone kind of smiled and jumped out. What am I not hearing?
You're missing a group.
Missing a group? What is this?
The project managers.
Okay. What tech stack, what computational design expectations do we have for the project managers?
They should understand that the tools exist. They should understand what they're used for. Not necessarily, they don't need to know anything about how to use them, how to do anything to them. They just need to know that they're there, that there's a group of people that are willing to help with them, and encourage the usage of them.
To recognize the opportunity on the project.
Recognize the opportunity on their projects.
It's going to be billable, they have to put it in the work plan.
Okay. So you're expecting from your project managers, when it comes to computational design, it's their responsibility to consider this as part of the work plan.
There's a bunch of design meetings, design process, and moment in the project for all that activity that happened. Then bring the specialists in the office into that mix, in the project, contribute to that.
On every project?
Sure.
Once the opportunity is recognized, then people will.
Even better yet, if you have the right tech-savvy person in place, maybe having a conversation really early in the project about if there is an opportunity at all and what the scale of that opportunity is, which is passing off to a domain expert that could help you out with that.
We do plumbing fixture counts and life safety diagrams and calculations on every project. The topic is so broad, broader than 50 towers, that I see this theoretically having applications potentially at every level.
Yeah, if we limit computational design to twisty towers, it applies to X number of projects. If we consider computational design automating repetitive tasks that we do on every single project, or however else we want to define it, augmenting our design workflow, all these things, then yes, I think there is a potential for space. What about principals, partners, CIOs, CTOs, CFOs? What expectations do you have for them when it comes to computational design? The same.
I feel like they're really more like advocates for it. Like they don't need to just know that it exists, they need to also insist upon it and say, hey, we've got people that know how to do this, are working on this, and can help you. So like let them help you.
Support is
Set standards, the expectations to the entire firm.
They're the ones
The
selling.
leaders.
They're the ones selling our services to clients, so if they include this as a service that we provide, then they made the argument for that to be financed as part of a project to be more complex solutions.
All right. Are there other people in our firms that we want to talk about or look at with this question? BIM managers? IT folks? Anybody?
BIM managers is interesting for me. We are in the process of hiring a BIM manager for each of our offices. We've been without a BIM manager for maybe about a year. And that's part of the discussion is should that person understand how to use Dynamo and Grasshopper? Should that be on their radar? Should they be developing tools for us to use? Or should they just be curating our families and solving warnings in our models?
Okay.
I'm the BIM manager in the Philly office, and I'm not a computational designer. I'm very new to it, but there are people in our office that have been doing it, and I want to be able to support them. And when they need resources, I give them the resources they need. If they need hardware, pieces of software, I need to be able to appreciate what they're trying to do so that enable them.
All right, so your second take-home assignment coming out of this conversation right now is I'm going to assume you are either tech-savvy, in this tech-savvy category, or you are in the able to potentially champion computational design in your firm type of person. You need to set up a meeting with one or more of your partners. And we'll discuss more about what's going to be in this meeting as we go. But I heard a lot of, I expect my owners, my partners, to be advocates. How can they be advocates if they don't see the business value in what you're doing? If we can show them truly business value, because they're not going to just do something because it's cool. If there's business value in selling a new skill, and they can show like, oh, look what we can do, that's business value, that's marketing. That brings in new clients. So we're going to talk about that more tomorrow, but that's your second thing to take away from this. All right. So I want to take a minute or two in groups to come up with a list, two lists. One, consultants that we've heard of or seen that do computational design. Two, firms that we have seen that do computational design well. So two lists here. One is consultants who are experts in computational design, and two, firms in general that we've heard of that do computational design. So can we take 2 or 3 minutes to write that down? All right, we're not going to be able to make a complete list, so in the next 30 seconds, focus on consultants for a moment.
Are you guys aware of any consultancies that just invest money on?
Pretty far from
That's, yeah, not the traditional, like, structure, whatever, they're purely BIM specialization. Computational design.
One of the
All right, now if we could pause, what is it about these people that makes you think they do it well? Together, just think about this in your groups. What is it about these groups? Think with your small teams. Keep going.
What is it that makes them stand out, I guess? So, like, I'm saying to you specific guys in Singapore, like, what happened in that situation? I was like, that's impressive. So roadmaps and standards, like they have strategies for
Looking at programs, looking downstream
sharing or marketing?
I'd say sharing.
She has sort of a sharing. It's emerging in
All right, if we can pause for a moment. I'm going to collect these lists separately and provide them to you in the feedback so we don't spend the next 5 minutes listing companies. But I do want to think about this last question that I put on here because I have some ideas. But I think as we think about computational design, we need to consider other industries. So what other industries have you specifically seen something you can take from, and what might it be? Yes?
Industrial design.
Can you speak up?
Industrial design.
And what about industrial design?
I remember AU last year and kind of the optimized forms they were doing for the Mars River and the shed.
Can I cheat?
Yeah.
I was just in a session, we were, and developers, so would use computational design for optimizing their sites.
Okay. Developers?
Software or financial, like building developers?
They use the software to make the decisions. If they need to purchase
Real
a
estate
site.
development?
But also arguably the real estate people are actually paying the money that's required to innovate, so all kinds of developers.
I don't understand. I'm a little lost.
He had to be there inside.
Gotcha.
Yeah,
Inside joke. Okay. All right.
I know what you're saying. That's all.
So we can borrow things from real estate developers, something about that industry, something about money in that industry allows for space for something. Is that? Can you explain to the rest of the room in one sentence or two?
So a product was just demonstrated at the last session that was software development for the AC space to try to turn all the stuff we've been talking about defining your constraints into generations of building form. And what they found was when they tried to approach architecture firms, they said, we have a computational designer, we don't need you. They went to the developer paid for them to do this prototype, and it outperformed what the architects did in their traditional. They didn't tell them that they were paying another company to just do a prototype and then outperform. So
I think also I'm going to add the other type of developers, software developers. My wife is actually a manager of a software development team, and I've learned so much. If you have a chance to be a part of a software if you're interested in computational design, and you have the ability to be a part of a software meetup, or go not to an AEC conversation, but to go to those conversations, you'll hear, oh my goodness, that's how you define problems? None of them are domain experts. Yet they write software like everything that we do. And so they learn that, but they learn how to figure that out. So that would be a space. I actually have been learning a lot about Agile, which is a way of doing work, which I don't know if architects do Agile ever, but structural engineers it's not a conversation we have much, but to think about that idea of like, ooh, what if I provided things in small bits? And there's so much more to Agile than that, but there's another industry, software development, I think we could actually grab things from by going to a conference. I've been a part of hackathons. The first 2 hackathons I went to, I did not know how to code. I barely knew how to do Dynamo at my first one. And the second one, I just storyboarded. Just created the PowerPoint. That was my job. But I learned so much about problems, how to define problems, and things like that. Yeah?
Data scientists.
Data scientists, definitely. Did you have something else, Kevin?
Lean manufacturing.
Can you explain a little bit about why?
So
or what you see?
In Lean, you're trying to define the problem, which is the biggest part. And then you're, well, in Six Sigma, if you're going to run that, you're defining it, you're looking for wastes, you're analyzing it, and developing a solution to that. It's a very rigorous method for limiting errors and waste. So in that, they may not be doing the problem like we're doing with repetitive problems, but they can define a problem. And I've often
Any other thoughts on today before we transition to tomorrow? All right, tomorrow. So we're going to talk, I want to focus this conversation on what I kind of hinted about earlier, and that is, what is the business problem, or what is the value that computational design brings our firm? And this is one of your key takeaways. I want you guys to come away with this idea. So can someone explain potentially how they brought a business problem out and how they were able to create a solution because they showed someone the value in the work?
So design problem. And so we had a project with 1,500 piles under the mat, and the client wanted us to place the pile caps true elevation based on a total surface condition. So every single pile cap was at a different elevation. They wanted to know where everyone was located, and then also apply similar principles to the base of the pile, where we were able to get accurate concrete estimates, and it aided some other parts and pieces of it, but essentially that it's 1,500 of these. If you were trying to locate these things manually, it was a massive and easy to understand all that.
So if I take a step back and I'm just a businessman, I'm the CFO, and you're selling me this idea of why you should be doing computational design. I know nothing about what you just said. I'm just going to pretend for a moment. Why should I be putting money into this idea that you have, Kevin?
There are two big things: is that you're going to save a lot of time, and the accuracy is going to be much higher.
So you know we're going to save time, and your accuracy is going to be better. You got about 10 more minutes. I'm about right. Is that right? Okay, so you know you're going to save time, and your accuracy. So you're telling me you're going to give me a better product, and you're going to save me time?
Better product depending on how you consider that.
Okay.
How many iterations of that are you going to go over, making sure you got it all right manually?
Okay.
Eventually you can get there, right? But if I'm going one-to-one data straight to tags or something in Revit that we're filling out, it's a one-step thing.
Okay.
So yeah.
Can someone else provide a problem where they identified the business problem and then were able to solve it, and it did show value? I want us all to hear these because I think we can learn in this situation. My first computational design problem I solved 5 years ago, I guess 6 years ago, was updating tags by subtracting them to 12 inches. So it was rebar, and someone had measured from the top of for PT beams, it measured from the top instead of the bottom. And so all the numbers said like 2 inches, and it should have said 10 inches because of a 12-inch slab. And so I was like, wait a minute. We don't have to redo all of this manually. And again, it was time. I was able to, and accuracy, because it was all correct. It was all back-checked. It was all right. We just needed to subtract the number from 12 to get the result. Talk about a simple design problem, computational design.
We had a lawsuit basically where our lawyer had asked us to show all the piles to the correct length based on the pile log, and they're already past piles, so there were 300 of them on the project, and a couple of them came up real short, and they just wanted a good visual to show everybody, and they were about to hand this off to an intern to sit there all day long and look at the pile log and plug all those things in, and I was like, I can do that for you in a couple minutes, basically. And was able to show them how quickly the tool would work for something like that. And I mean, that alone just got me enough, basically, credibility to, in the future, when things come up, to at least have the chance to look at it first. And occasionally, if people remember, like, oh, wait, this might be something we could automate, and they'll actually come to me. But it gives you that